Independent events. Two events are independent if the occurrence of each event does not affect the occurrence of the other. So the odds of one event do not affect the odds of the other event. That's what it means to say there. So best way to do this, let me give you a quick example. A bag contains 10 marbles. A bag of 10 marbles has 6 red marbles and 4 blue marbles. So we have 10 marbles total, 6 red, and 4 blue. Find the probability of randomly selecting a red marble, then another red marble if, so when we get red, then red. Let's look at A here. After selecting the first marble, the marble is returned to the bag. So odds of getting a red marble is going to be 6 out of 10. And then what happens, we return that marble we selected, we put it back in the bag. So the odds of getting a red marble again, well, let's be 6 out of 10. And we'll talk about what to do with that afterwards. Now let's look at option B. After selecting the first marble, the selected marble is not returned to the bag. So in that case, right, the first time we do it, odds of getting red are 6 out of 10. But in here, we're not going to put the marble back in the bag. Now there's one less marble. And in this case, now there's 9 marbles total. There's only 5 red. We selected red earlier. And there's 4 blue. So the odds of getting red the second time would be 5 out of 9. So this right here is, see how the odds change this time? This is not independent. We actually call this dependent. That's the next lesson's going to be on. Because the odds changed the second time it went around. The first one here where we put the marble back in the box, this is an independent event. Since we put the marble back, this reset the timer basically, and now it's all the same. The odds of getting red will be 6 out of 10 again. So when the first time you do it, the first event and the second event have no effect on each other, and this one doesn't because we return the marble, then it's called an independent event. And the way you find the odds of this happening and that happening is right here. You just multiply them together. Now this actually is the formula uniform machine, like why it's too easy. A lot of times we use this to verify things are independent. They'll say, are these things independent, yes or no? You use this formula to check if they are independent or not. So this is a formula uniform sheet, and mostly we use to check independence. See if that thing holds for independence. What happens if you have 3 or more? You just multiply them all together. So that's what this one says. If you have A, B, C, or independent events, you just multiply them. That goes for 3 or 4 or 5. How many independent events you have, you just multiply them all together. So let's do an example. A coin is tossed and dice roll simultaneously. Determine the probability of getting a head and a 3 without using a grid. So without using a grid, right? So the odds here, you want to get a head and you want to get a 3. So if we roll a coin, you have 2 possibilities, heads or tails. So odds of getting a head would be 1 out of 2. When you throw a die, you have 6 possibilities, 1 through 6. Odds of getting a 3, well, there's only 1 3 there, so 1 out of 6. And then again, these are independent events, right? If I get a head, it does not affect how I get on my roll of my die. These are independent events. They don't affect each other. So you just multiply them together and you get 1 over 12. Now again, you can do the same thing if you want with the grid. You go heads and tails. And then you go 1, 2, 3, 4, 5, 6. You'll see there are 12, 2 times 6. There's 12 total. And then a head. A 3 of heads right there. So it'll be 1 out of 12. So you could do it with the grid, but it's a lot easier if you just understand the probability and multiply them together. Next example. Archer hits the bullseye on average 2 out of 5 shots. So bullseye is 2 out of 5. If 3 arrows are fired at the target, determine the probability that the bullseye is hit every time. So every time we're going to have bullseye. So odds of getting bullseye the first time, 2 out of 5. The second time, 2 out of 5. The third time, 2 out of 5. So let's multiply these all together, and we're going to get 8 over 125. B, the first 2 times, but not the third time. So odds of getting a bullseye, so this is, let's say 1, 2, 3, shot 1, 2, 3. So odds of getting a bullseye, 2 out of 5. Odds of getting a bullseye, 2 out of 5. Not getting a bullseye. So a bullseye is 2 out of 5. Not getting a bullseye, remember the way we do not? It's 1 minus this guy. So 1 minus 2 out of 5. Common denominator, or just 3 out of 5? Right, common denominator. Or basically just what's opposite of 2/5? 3/5. So 3 out of 5. In this case, we get 2 times 2 is 4, 4 times 3 is 12. out of 125. And then the last one here, on no occasion, so all 3 times we missed the bullseye. So again, odds of not getting bullseye would be 3 out of 5, because odds of getting bullseye is 2/5, so you subtract from 1. So you get 3/5 times 3/5 times 3/5. We're going to get, what was that, 27 over 125. And there we go. Okay, let's do the next one. Carl's not having much luck lately. His car can only start 80% of the time, and his motorbike only starts 60% of the time, independently of one another. So they don't have effect on each other. Draw a T-diagram to illustrate this situation. So we're gonna be here. We're gonna try to start our car. So it doesn't, in this case, they're independent of each other, so it doesn't matter which one comes first. We'll just put car first. So car, let's put start and won't start. So it's usually start and not start. So start would be 80% of the time. So 0.8. And not start. So here's the thing. When you do a tree diagram, this whole tree, this one branch should equal 100%. So if this is 0.8, 80% time, that means it doesn't start 1 minus that, or 0.2. So then after we do car, we're going to do motorbike. And it's going to be the exact same idea. It starts or it doesn't start. And remember, they are independent, so it doesn't matter. So it's either going to start or it's not going to start. And this is for the motorbike. And it starts 60% of the time, which means it doesn't start 40% of the time. And we do the same thing here. So start and not start. This is the motorbike. It's 0.6 and 0.4. So there's a tree diagram. Draw a tree diagram to the situation. Done. Use a tree diagram to determine when the chance that on the next attempt both will start. So let's do that first. So both start. So for me, that would be S and S. So all we're going to do is follow that path. So this path and this path. And again, all we do, since it's independent events, is multiply them together. 0.8 times 0.6, which would be 0.48. There we go. Next one. Car can only use this car. So only this car is going to work. So let's illustrate that one. So that means his car starts. Oops. I'm supposed to highlight. There we go. So his car starts, but the motorbike does not start. So it's that path right there. Right? So he could use his car, but he could only use his car. So car and not motorbike. So that would be S and then S prime. So 0.8 times 0.4, which is 0.32. So there we go. So that's how you do branches in a tree diagram. You multiply the branches together. And that's the one you want. Next one. Liam rolls a 6-sided die twice. This front probably exactly 1 4 is rolled. So here's the key. It says exactly 1 4 is rolled. So we're going to roll it 2 times. And we want to get 4 in some number. 4 and not 4 basically, right? Because you want to get only 1 4. So 4 4 is not good for us. Getting this is not good. So we want 4 in something that's not 4. But we could also go the opposite way. We could get not 4 in something that is 4. Anytime you have options, I could get this or I could get this. What we do to solve that is we add up the probabilities. So it'll be the probability of having this plus the probability of having this. So what's the probability of rolling a 4 when we roll a die? Well, remember a die is 1, 2, 3, 4, 5, 6. Odds of getting 4 is 1 out of 6. And the odds of not getting a 4 would be 5 out of 6. And I could do the other option where I don't roll a 4. So that'd be 5 out of 6. Plus rolling a 4. Or multiply rolling a 4. 1 out of 6. Remember, we multiply these up. Because these two are independent events. So multiply these up, multiply these up. Since we have an OR statement, it could do this or that. We're going to add them up. We get 5 out of 36 plus 5 out of 36, which gets us 10 out of 36. Is odds of rolling exactly rolling exactly 1 4. Now another way we can do that, we can do that with our grid, which is always a good way of doing it with rolling die. A little time consuming though. So we did our grid 1, 2, 3, 4, 5, 6. And just as quick as possible, but it is time consuming. we go. And then 1, 2, 3, 4, 5, 6. So same thing over here. These are not as straight as I want them to be. Okay. Right, and we have the odds of getting exactly 1, 4. So here's 4. I get 4 and 1. Let's do it a little darker. 4 and 1. I could get 4 and 2, 4 and 3. I cannot put this one. This would be 4 and 4, which would be more than 1, 4. So skip that one. I could do 4 and 5, and 4 and 6. Or I could do the other die, where I could do 1 and 4, 2 and 4, 3 and 4. I can't do 4 and 4. I could do 5 and 4, and 6 and 4. Right? Look how many things I highlighted. Exactly 10. So if you do it that way, you also get 10 out of 36. So either way, we get the same answer.